Good morning, guys. It's Naveen joining the call. Can you guys hear me? Could you please type in the chat window? Great. Thank you, Rahul. Today we'll get started with a little bit of Openstack, and then we'll move on to back to the Google Cloud, guys, on a daily basis. The first 1 hour, maybe I'll dedicate it to the Openstack, and also the second hour we'll dedicate it to Google Cloud. And we'll dig into a little bit of more scenarios. And let's see. Pardon me. So Aniket, a few days back, I think I remember you asked me to cover up a few scenarios and things like that. So I'm still working on them, and I'm still trying to prepare a few samples and use cases. So just give me a little bit of time. In the meantime, I thought I will just go ahead and get started with these so that I can get some time in refining them and finalizing them. So once I'm done with them, in the coming up days, I will cover up them, Aniket. Aniket, did you get the message? Pardon me. Rahul, did you, can you hear me?
Yes, yes.
Okay, sorry about that. Pardon me. Okay, so let's see. Rahul, are you able to access the dashboard?
The Openstack. Yes, yes.
Yeah, yes.
Yes.
Okay, I'll probably ask you to get onto that one if time permits today. So just be on the standby. And
Okay.
thank you, buddy. So let's get started with Openstack. It is a cloud computing software platform that delivers infrastructure as service. So that is one definition. It is a platform which is providing us the infrastructure as service capability. So we think of software-driven compute networks and storage. In other words, short and sweet, the compute networks and storage are the physical devices, but using the software, we are going to manipulate and use these things in various permutations and combinations, their capacities and capabilities and various permutations and combinations. That is what Openstack will allow us. Part of compute, part of network, part of storage and things like that. Physical resources in the data centers are pooled and placed in let's say, under the control of Openstack software. So in other words, again, pool is nothing but a group of computes, the process, RAMs and things like that. Networking is network, storage is your hard drive, SSDs and things like that. A pool of them is nothing but a group of them. We can use them in various permutations and combinations. Although they're at a physical level, we will try to use that infrastructure from a software perspective. So we're referring that as a software-driven resources. Openstack will give you the ability to securely create instant infrastructure over the internet or a private network. In other words, we can instantly create the different kinds of combinations of infrastructure using Openstack. We can scale our infrastructure up and down, scaling up and scaling down, scaling out. You might be familiar. If we are increasing the capacity of a computer, adding more processors, RAM, and other components, that is scaling up. Whereas if we add more and more servers, we are commissioning more and more servers and decommissioning more and more servers. That is referred as scaling out and scaling in. So scaling up and scaling down is one where we are increasing the power of our computer and decreasing it. Scaling out and scaling in is where we are adding more and more nodes and removing the nodes based on our usage and so on to save the expenses primarily. Okay, so high level diagram. So this is a slightly high level look. What we have is at the bottom, we have common network. The network is connecting the various components of the cloud. The bare metal servers. On top of bare metal servers, we have the operating system. On top of operating systems, we have Openstack software installed ideally. On top of Openstack, We create virtual machines, we create different kinds of instances, containers, and the data related to the Openstack. It can be stored in different ways: object storage, file storage, block storage. That's what we also briefly discussed yesterday. And we'll try to look into those things, guys. Control plane is more really going a little bit deep into it. It is a network, or in other words, that's control plane is referred as a controller, and the compute part of the controller and the compute part of the OpenStack nodes. I think it's too early for me to talk about it, so we'll talk. Then we have a dashboard or a GUI where we can access the OpenStack software using a GUI. We can also access it using a CLI. The third way of accessing it is directly messing with the database, but generally not a recommended practice. Behind the scenes, OpenStack has a lot of projects or services. Every service uses its own database, unless and until we are troubleshooting some techniques and things like that. We wouldn't really touch these databases. It is the water under the bridge. We shouldn't have to touch them. But there are ways in which we can directly, if you're an advanced user, you can directly go ahead and execute the commands in this database and have the projects, the computes, the instances created, but that is generally not a recommended way. There are also different kinds of monitoring and other kinds of tools as part of the OpenStack. We will also look at them, guys, okay? So how is it? How is the OpenStack software architected? OpenStack is not one large monolithic piece of software. So if you're hearing these days, there's a lot of talk going about the microservices and things like that. So prior to the microservices, everything was, or in other words, a lot of it looked like a monolithic software where a project is really a huge code base, and that is generally referred as the monolithic software. And so in other words, the problem is if you make a change at one place that may have a lot of dependencies, it may have many impacts at other parts of the code, and the system may not be stable, or the application may not be stable. So that's where the birth of the microservices, service-oriented architecture, and many other kinds of architecture came into the picture. So today, OpenStack is organized as a collection or a group of projects. These projects are also known as services. Technically, we refer to them as services, but behind the scenes, they are projects. Each project ideally has multiple services inside them, is what it is, guys, okay? And we'll try to look at them. Each project is responsible for automating some part of the infrastructure. So we have Nova, which is taking care of the compute, where we have Keystone, which is taking care of the identity management, like I am in GCP and AWS. Then we have Neutron, which is taking care of the networking part of it, and so on. So all these projects are separate open source projects. They are free, or in other words, they're open source, and they do different parts of it. They also have internal dependencies and external dependencies on other projects, guys, okay? So each project exposes a set of well-defined REST APIs, again, representational state transfers. So which means each of these projects or services, we can programmatically access them and get the work done. We can create the instances programmatically. If time permits, we'll also try to do that using a programmatic example. Projects are also integrated. One project can use the services of another to fulfill a request. In other words, some of these projects sometimes. So in other words, without networking Neutron, the others may not work. Without computing Nova, the others may not be of any use. Without storage also, we may not be able to use, make a good use of the thing. So in other words, each of them are dependent on others and vice versa. And they are capable of working independently. In other words, each project can be taken separately and also installed separately and worked separately, yes. But let's see. So the OpenStack Foundation provides an independent home for OpenStack. It was founded in 2012, 82,000 community members. The goal is to serve the developers, users, and the entire open ecosystem. It organizes a large-scale test infrastructure. So in other words, there's a lot of community help being done in the world of OpenStack. So although these days it has come down a little bit, but a lot of work was being done, and a lot of testing needs to be done. So that is what is large-scale testing infrastructure. They need a lot of infrastructure itself, so they need a lot of money and things like that. A lot of companies actually sponsor them, and there are these mega companies who make mega donations, and they're also referred as the platinum companies and things like that. So incubate new projects in strategic focus areas. So more and more projects, a lot of projects have been added into the OpenStack. And global events, there are also some summits and things like that which are happening. Okay, guys, a little bit of theory, just bear with me. So it was born in on 21st October 2010. The code name was Austin. And it began as a joint project between Rackspace, hosting, and NASA, just for the sake of discipline. So Nova was earlier referred as a cloud fabric controller. It is more about the compute, EC2 of AWS. That's what the Nova is. It was originally developed by NASA, and Swift was coming from Rackspace company. They are a huge data center, one of the they have data centers just like the Google and other data centers around the world, and they developed a project called Swift, which is similar to Amazon S3. So by the fulsome release, which is in September, OpenStack had a total of how many? I think, let me say 7. Okay, 7 projects. These are some of the core projects. Neutron, which is more related to the networking, was earlier referred as quantum. Nova is the compute, Swift is the storage, Glance is the images, Horizon is your GUI, Keystone is your identity management, Cinder is also, block storage, I think, from what I recall, but we'll see, guys. So most stack projects follow 6-month development cycle, so that is just something to be kept in mind, maybe once in a lifetime. If you are familiar with these points, it's always a good idea. So suddenly throws something at your client, throws something at you, you just want to make sure you're familiar with it at least, guys, okay? So OpenStack uses a time-based release model, results in a single release at the end of the development. So every 6 months, they're making release, although I think the last release was in 2017. After that, I think they did not make a release. These are some of the names they came up with. And with every release, they're introducing new projects and new services, guys, okay? So Pike, I think, is the latest one. And so what does open mean in OpenStack? OpenStack is committed to openness. So the first one is open source. Open source is free. Everything, all the source code is free and open. There is no enterprise edition. In other words, there is no closed edition. They're not hiding anything. They're just opening up everything. OpenStack is truly open source from day one. It is designed to be secure, usable, and scalable. So again, pretty self-explanatory there, nothing much to simplify. Open design, public software design summit. So in other words, the design, if you have some good thoughts and things like that, we can also become contributors, discuss with them, and try to bubble up and attend the summits and present them. That is also there. Open development and open community. So everything is being developed openly. We can, as I said, we can go ahead and become part of their community and try to contribute to them if we are also interested in that, guys, okay? So OpenStack has 6 core projects at this time. Ecosystem has a combined total of over 45 projects. Projects related to several cloud services, deployment, monitoring, and management tools. So all stack projects are classified based on 3 factors. So each project based on their percentage of adoption, percentage of production deployment, how many of them are used, what is the percentage of the people using in production versus the maturity, how many bugs are there, and how is the support from each project. So each project will have again their own separate community. Based on that also, they are classified. And based on the number of years the project, so for example, Nova and Neutron have been there right from the day one. And so based on these 3 things they have, and they're classifying them as which of them are the core versus the, so here are the core projects: Nova, Neutron, Swift. Swift is for object storage, Glance for images, Keystone for identity, and Cinder is for block storage. Some other popular: Horizon, Heat, orchestration, Ceilometer. We'll briefly talk about them, guys. We'll mostly focus on the core. and try to get an understanding of these things. And moving ahead, so in deployment, OpenStack deployment has one or more nodes. And a node is typically a physical server on which OpenStack services are run. A node could also be a VM in development and test deployment. So short and sweet, a node is a node. Sometimes we can refer the virtual machine as a node. It's a soft machine. It's a software which is acting like a machine on a physical machine. A physical machine can contain multiple virtual machines, is what it is. An all-in-one AIO node is a single machine that performs all OpenStack cloud functions. So in a Linux world, a lot of the large and enterprise projects, they also provide as an all-in-one a node or a VM where they have all the services installed, and we can use it as if it is a real cluster of nodes and things like that. Ideally, each service is in an enterprise world is deployed into a separate node or a server. Even if we work in an all-in-one node, we will have the similar experience as if we are working in a cluster of nodes only, guys. Okay, we'll try to understand that. Cloud controller node, that is a central management system for the OpenStack, that is a master. There's something called a master worker architecture in the world of Linux world and things like that. The controller is the master and one of the main nodes, the brain of the entire cluster of nodes. It is deployed in a redundant configuration and an active standby mode. So generally, an enterprise class server, which is generally expensive servers, are used as a cloud controllers. And when we use enterprise class servers, generally there's a hot standby just in case the primary server goes down. The secondary server picks up its requests, and they will start serving the requests in case of the primary server going down. So that is referred as a redundant configuration and an active and a standby mode. Rahul, do you have an idea of active and standby mode?
For the failure purpose, if the primary gets we can use the standby.
As simple as that. So in other words, if the active fails, the standby should pick up hot. No request should be lost. That is generally how the enterprise class servers. Then we have the commodity servers, which are generally not the enterprise class servers, so they're not really active standby. Okay. So a little bit of the controller node, we'll talk about that. Then another type of node is a network node, and it provides networking services to OpenStack tenants. So we have layer 3 routers, gateways, NAT services, routers for connecting the internal private network, private VMs and things like that. Metadata floating IP services, this is for reserving the IP, giving dedicated IPs and things. Advanced services such as load balancing as service and firewall as service. The network is referred as a network node. Then many Neutron service agents reside on this node. So layer 3 DHCP, layer 2 Neutron metadata. All these are more coming from a networking standpoint. DHCP is routing the packets within the network. Layer 3, layer 2 are used for creating the routers and other kinds of network related components and so on. And just a high level idea there. And the network node is also deployed in a redundant configuration, which is generally an expensive and enterprise class server and so on, guys. Okay. So Rahul, if you find anything where you want me to explain, just feel free to stop. I'm just covering a few basics of basic theoretical aspects of OpenStack, but you let me know, okay? Okay. Compute nodes, they runs the hypervisor. Hypervisor is nothing but when you want to run a group of virtual machines in a physical machine, that's what the hypervisor does. Your VMware, your VirtualBox are also referred as hypervisors. So using them, we generally run a group of virtual machines and so on. So compute nodes run the hypervisor. Instances are scheduled on this node. So when we create the instances in OpenStack and things like that, the compute nodes are used in such cases. All the computations and other kinds of things happen on compute nodes, so they're referred as the compute nodes. The instances are actually sitting on them, and the data might be sitting separately on other volumes and storage nodes. The type of CPU on a compute node must support virtualization features. So again, virtualization should be enabled so that the hypervisor kicks in and it can do its work. The number of CPU cores is also important. CPU cores are allocated to the VMs as virtual CPUs. So we are using our software. Our CPUs are being treated as virtual CPUs. So here is a calculation for how many virtual CPUs they would end up or calculate to. Overcommit ratio is when we have a machine and when we try to accommodate more instances, a lot of instances on it, even at the cost of giving up the performance of the computer, that is generally referred as the overcommit ratio. Even though your machine, imagine in a machine, we can only save maybe 10 or 20 instances, and you want a decent speed or a performance. But let's say you have a huge requirement coming up of maybe 50 instances. You do have the storage, but the performance will be low. What are you doing? You're overcommitting it. That is referred as overcommit ratio. So here is a formula for calculating the virtual CPUs. So a node with 2 CPUs, 24 cores and 16 overcommit ratio will end up to be 768 vCPUs. If you're hyper-threaded, everything is doubled. It is much more performant and makes everything double. And NUMA support is recommended in the compute model. So NUMA, Uniform Memory Access something, something like that. So that is more precisely pardon me, the hardware of the nodes for them to be more performant and things like that. These are some settings somewhere, and these are all the ones which are being used to make it more performant oriented. Okay. Moment. Okay. That's again for protecting the operating system, maintain system and network performance, all these things by using NUMA. And deployment typically contains several computing nodes. So in other words, in a production environment, ideally, we might end up saying multiple nodes. There might be 10, 20, 100, or maybe thousands of nodes. Also in large enterprises and things like that, where they are using it as a private node. And compute nodes are grouped and placed into availability zones and host aggregates. Again, computes can be in different availability zones and regions is what that really refers to. Storage types. Openstack provides 3 types of storage. Yesterday, we briefly talked about that: block storage, file, and object. So block storage provides persistent storage volumes to VMs. In other words, VM disks are ephemeral. So to understand the block storage, generally when we create a virtual machine, the disks are ephemeral means if we terminate the virtual machine, whatever the data that we have on the virtual machine is lost. So that is temporary, that is what is ephemeral. If we would like to save those, the data related to the virtual machine, we can hook up additional volumes, additional drives and things like that. And that's where the block storage comes into the picture. So since we are saving it even when the VM is gone, we are referring that as persistent. File-based storage, again, enables VMs to mount a remote file system. So it's just like accessing a network drive or a network system for sharing the data. These are some of the protocols which it supports. HDFS is Hadoop related, the big data and all those things you might be hearing. So that is also supported here. Pardon me. Okay, so OpenStack Swift provides object storage services. So Swift is used for object storage, and it is one of the core components of OpenStack. Users can store and retrieve binary objects using Swift. The binary object is in any file format that could be a video, audio, or maybe some other PDF for a complex format. It is nothing but it is the similar to the Amazon S3, and it replicates stored data within the cloud for reliability. So in other words, it also gives a replication features that we have on Amazon S3, where when we store, if we happen to store a file on Swift, it is behind the scenes replicating it. And just in case if one of the server goes down, it uses its replicas and serves the request and make sure that the data is always available. So some of the use cases: Dropbox, file and document storage, disaster recovery, VM images, backups, HTML. This is nothing but the unstructured data and things like that. All these things can be stored on Swift. And we'll talk in a bit more detail in the coming updates about Swift, guys. I'm just giving a quick introduction here. So again, ephemeral is non-persistent, something where when we do not save it, that is ephemeral. It is generally comes with the default virtual machine. When you created a virtual machine, the default disk that is given is referred as the ephemeral disk. So life cycle coincides with an instance. So instance is again, when you create an instance, when you close down an instance, you're giving up the data, or your data is not getting saved. Usually local file system or QME CO write file. So in other words, that's like an image, which we'll also talk in a bit. It comes in a local file system for installing it, for installing the instances and image is what it is, guys. Okay. Block is Cinder. Cinder is a separate project or service which gives us the block storage, and it's persistent storage, volumes to instances. So it can be attached and detached as needed. It's as if you're plugging in some additional hard drives and things like that. That's what Cinder is. And raw disk functioning like a detachable USB drive. So that is like a detachable drive. Shared FS, several instances can mount a remote file system and share data. So these are things we just I just talked a little bit. Then we have Swift, which is cheap and reliable, uses a commodity service most of the times. Think Dropbox, much more cheaper. Dropbox is what we can think. Frees the developer from storage concerns. So it gives its own fault tolerance and other replication and many other things which otherwise, in the absence of these applications, developers would have had to write a lot of code in taking care of these things, guys. Okay. So the photos, documents, all this is unstructured data, binary data. We can store it in Swift, guys. Okay. Okay. Some of the services generally install in the controller. Message queues. So SQL database is the entire or the global state of the Openstack. Behind the scenes, Openstack is saving all the data in the controller's database, and that has a snapshot of the metadata or at a global level for all the common things related to the Openstack, whether that is networking, whether that is compute or any other thing. Generally, we do not have to go into a database and mess with it and understand the models within the database. But it is a good idea to have an idea. Message queue messaging is generally used between different services to communicate among themselves. The RabbitMQ is the message, is a project or service which is generally used. And network time service, okay, that's for time. Keystone for identity, glance for images, and so on. These are things, some of these things will go in little detail. Nova, if you notice, Nova API conductor. Then we have scheduler and metadata agent. I think somewhere here should be, okay. We wouldn't have Nova compute here, but that is, Nova is for computing aspects of the thing. So a controller node, apart from all these services, is generally hooked up with two NIC cards. One is for management network, another one is for API network. In other words, the external world connects, uses the API to the controller, and they can access the data. And controller will look into its SQL database and return the data based on the credentials and so on. Management network is for internal communication between the other nodes, the compute nodes, the storage nodes, and the other kind of nodes that are there as part of the cluster. Then there is a compute node. Within the compute node, we have a KVM. Now a compute is a separate daemon which is working with the KVM. And L2 agent and Open vSwitch, these are taking care of the creation of the various kinds of interfaces, routers, and things like that at a software level, which are being used by the Nova Compute guys. Okay, so these are things, again, we don't have to worry about the internals. Compute node generally has 3 cards. One is for the management, which is for the communication with the control plane. So the compute node comes under the data plane. We'll one more time look at the, we'll try to understand what is control plane versus data plane in a day or two. But its connection to the controller node is via through the management network. And storage network is for storing any additional volumes and drives. Data network is for the rest of the world and the external data and things like that. So network node, again, routes the traffic between the project networks. So we create different kinds of projects. We create different kinds of virtual projects, virtual networks, all that data is being routed using the network node. And that could be within the internal networks and also the external networks. A network project network is a self-service virtual network. So it is like a virtual network created by us in user in Openstack. The network node is critical node, provides network services to Openstack tenants. And if it goes down, it will impact all the external in the project network connectivity. In other words, if you don't have the network connectivity, you cannot connect to any of these machines, is what it means. And we will talk a little in detail about the Neutron project in the coming up days, guys, okay? So there it is. These are the primary components, 3 cards generally in a production environment, minimal of 3 cards are there. Then we have the storage node. The disks that we are seeing in the green region, or the white disk we are seeing in the green region, are nothing but the volumes. The logical volume management is what is LVM. And you can take a single disk and divide them into multiple volumes or multiple disks into multiple volumes and things like that is what is handled by Cinder, is what it is, guys, okay? So again, a couple of cards there, one for the almost whether you're a storage node or a compute node, they're all reporting and in communication with the controller node. And the rest of the nodes are using the ISKey protocol. These are some of the services which are generally running in a cloud controller or a controller node, to be more precise. Neutron is for networking. SQL database is for saving the global snapshot of the state of the Openstack servers and everything. Nova is the compute. Keystone, again, identity. MQP is for internal communication. Cinder is for the storage. And dashboard is nothing but the GUI that we will try to see in a few minutes and get a quick feel of it, guys, okay? Then again, we have one card which uses the management network. Another one uses a external, used for external network. Then here is the compute node, or this is the network node. Then we have the compute node, and here is the storage node. So this is a slightly high level design of the Openstack components and their components, guys, okay? So it is slightly more, this is maybe we can say this is the physical design, this is the logical design of different components and things like that, how they interact with them and so on. And the details of each of those things are also, we'll spend a bit of time in the coming up days, guys, okay? So we can also say Openstack is not only a platform for infrastructure as service, but it is acting like a content management system. The dashboard, the CLI GUI, which is used to create, delete, manage virtual devices and services. These are some of the things that we generally do. The physical resources, they're acting like virtual devices, and whether it is public or private, we can use Openstack. And that is the horizon GUI. And what's your name? Rahul, can you also make sure while I'm covering some of the slides, buddy, can you also access the console and just be ready? We'll just have a quick look, try to execute a few commands and get a feel of that, please.
Yes.
Okay, so what we are seeing here is on the right hand side, the physical view is nothing but a group of racks, a bunch of servers plugged in and things like that. On top of them, is the Openstack, which is acting like a management system for all these using these resources. On the left hand side, the one in the light blue color is the hardware. It could be HP or Dell or something else. Generally, when you buy hardware, you get their own operating system, the CentOS, Red Hat. Most of the time, production environment is Red Hat, and there could be other Linux distributions also. So together, these are the two things which we generally get when we purchase, when we buy a server. And of course, we can also buy the bare metal servers and also install based on our requirements. Cloud management system sits on top of it, is what it is. Okay, so by the time we work with these servers, we would have hardware with already installed Linux distribution is what it is. There are about 25 distributions of OpenStack, and these are some of them. So we can kind of think, putting it in a slightly simple way, if we were to take a virtual machine has many components inside it. One is RAM, one is hard drive, one is processor and things like that. We can kind of think Nova is the computation part of it. The processor and the RAM, I would say, is the computation aspect of it, is what is Nova. Then we have Glance. The Glance is nothing but when you buy a computer or when you get a virtual machine, you have some kind of a Windows or a Linux operating system installed on it. So what is that? That is an image. So Glance provides these kinds of images. Neutron is networking. You're plugging in the cables and having it network with your rest of the computers and so on. Cinder is external hard drive. And Keystone is the user access management, from a Windows perspective, where you're doing the identity management. And there is a Horizon GUI where we can create the projects, users, and virtual networks and so on, guys. Okay, so that's how UI for Horizon will look like. We'll try to have a look at this on a friend's machine here. And PM creation OpenStack components. Okay, so Rahul, can you quickly bring up your screen for a moment? Let's get a host. Okay, already co-host. Okay, so this is the Horizon GUI. Some of you might be already using it and you might be already familiar. So I'll go a little fast, guys. If any of you are not much into it, feel free to let me know. I'll try to explain some of the things and so on. So ideally, we have a project on the top, and on top of the project, if you see, by the side of the OpenStack symbol, we have an admin. There's an admin drop-down list box on the top. Yeah, click on that. So, okay, right now we have only the admin there. That's listing the projects, and it says as admin. So in other words, on the right-hand side corner, yeah, if you look at that, there is the settings. We can sign out OpenStack RC file. Okay, we'll come back to that later. So there is a project. Under the project, we have API access, compute, and under compute, we have instances and so on, and admin and identity. This is the Horizon GUI. And let's say, since we are admin, let's see, click on, you click on the project. Okay, on the right-hand side, just to create a new project. Below, you see a project, or expand identity. Okay, click on the projects. So ideally, this is where we can create a new project. Generally, before we create a new project, we'll create a new user, then we give them a role and an admin. And then we will create a new project and assign that user here. It looks like by default, we generally have admin and service, the two projects. And also, can you click on the users, please? Users on the left-hand side, yeah. Notice some of these. Admin is like one second. Okay. Okay, so if you notice, we have cinder, glance, and nova, neutron, heat. These are nothing but they are sitting there as users, but ideally they are nothing but the services and things like that, guys. Okay, nova, neutron, and cinder is there. Displaying 8 items. Okay, we only have 8 of them. All right. Then we have groups. Just click on groups. We'll later try to create a group and a role and things like that in coming up days. But I just want to quickly go over here. Groups are nothing but a group of roles. A role is nothing but a group of users. Users' permissions and things like that are generally configured in a policy file. And click on application credentials, please. Project ID. Okay, this is where we can give different kinds of actions. Okay, back to admin. Go back to no, in the middle. Yeah, expand that and click on overview. Okay, so this is more precisely what I'm trying to show you is a quick look at if you want to see what are all the projects there, what are all the instances, what are all the thank you, Rahul. What are all the VMs there and things like that. This is a GUI way of looking at it. Most of the time, more than the GUI way, we will use the CLI to look at them, and we'll use the Openstack commands is what it is. So right now, can you scroll a bit, please? So there's a expand the compute, click on compute. So click on hypervisors. Okay, scroll down. So it looks like we have U compute. So it looks like this configured with 2 computes, compute 0, 1, and 2, and vCPU usage. Okay, click on U compute 0, 1. Okay, this compute has a bunch of instances and things like that. Click on an instance. Okay, so there is an overview of the instance. So let's say description is, that's Shubham's and it's active. Its availability zone is age is 3 weeks back. And let's say there's a private IP and there's an external IP. Scroll down, security groups. I think these are all the ports and things like that, which are open and closed. And metadata, volumes attached, no volumes attached. And then click on the log tab. So these are all the log files which are getting coming out, and since we are using, I think you guys are using maybe a 2 or 3 node thing. I logged into this a few days back, but ideally we need to have an understanding of where to look for the logs and things like that at a CLI perspective, so that we are looking at the right logs and be able to troubleshoot them properly. And let's see, right now not much is going on there. Then click on console. So we are actually accessing the Linux box from here, and whatever is the username and password, we can log into it and try to perform all the actions, look at the various log files. This is one way of accessing it, guys. Okay. Other one is our using our CLI directly. Then just click on action log. Okay. Click on any one of the user IDs, please. The links on the right hand side. Yeah. Okay, so this is the admin user. He's the default. He's a super user. He's like the root user, guys. As simple as that. Role assignments. A group of users are generally plugged into a role. A group of roles can be plugged into groups. Sometimes roles and groups are used interchangeably, guys. So here admin is again the admin, the big one. The groups, please. Yeah. Okay, no groups there. It's okay. And the groups on the left-hand side. Then the roles. Around the same thing. Yeah. Okay, go back to the admin in the middle. Expand that. Let's see. So in the coming updates, we'll dig a little bit deep into these things. Click on system, please. Defaults, metadata definitions, and so on. So this is a quick look from a GUI perspective, guys. We'll do a few of things here. The GUI is generally not 100% powerful. More powerful is CLI. Any of the projects, any of the resources that we create using the GUI can be done using CLI, but not all the things which can be done in CLI can be done in GUI. We can also directly access the database and do these things, but generally not a good idea. That would be like a hack. Unless and until it is really needed, we don't need to go that far, is what it is. Okay. Then can you bring up, open up a terminal? Open up a terminal on this one, Rahul. Let's see again. Oops.
Server is low.
Yeah. Can you increase the font size a little bit, please? Increase the font size. Okay. Just one more time. Okay, decent enough. That's good. So again, we'll do a few things. So it looks like, what are you doing? You're doing admin open. Okay, you're playing around with somebody's playing around with the admin open RC. Okay, so it looks like OS authorization URL 74.
Yeah, here there is a password for this dashboard.
Oh, sure. Okay. So you that is the IP address for the dashboard, right? The horizon, right?
Yeah, this is useful. When we are logging, this is the username. For credential, we need to add this one. Admin
Gotcha.
users.
Copy that. Good one. Okay, looks like yeah, I think it's me who did some of this stuff. Let's see, what is first thing? Okay, just do head minus n, head hyphen n. Let's say 5, number 5 / etc / password 5, number 5 space / etc / password EASSWD WD, yeah, enter. So again, the passwords file, the daemon bin. So if you notice, the top one is root is the super user and things like that. Then we have daemon, bin, and so on. And just for sake of simplicity, cat the etc password, cat the file. Looks like we're in controller node. And if you notice here, if you scroll up a little bit, these are all the usernames you're seeing on the left-hand side. And where is it? Scroll down.
Server is slow.
Pardon me. Okay, so basically some of the things that I've been looking for is the services generally register themselves here as Nova, Cinder, all those things are also generally there as usernames and things like that. Okay. Okay, let's see. Why didn't you say user add? Let's add a user add. User add, and let's give you a name, Rahul. Space Rahul. And give some password, your own password, maybe just say Rahul. You can give just Rahul. Keep it simple. And then tail the etc password. Okay, so there is Rahul. Rahul is last one, which is added gas, as simple as that. You guys might already have an idea about this one, but I'll tell you why I'm trying to explain this one or show this one to you in a moment here. And let's say you're already, just type in OpenStack and enter. So we're already into OpenStack and just say which OpenStack. Policy, do you mean? Oh, okay. Just quit out of that. Quit out of the OpenStack prompt. Now say which OpenStack. Okay, so it's running from there. And let's say, I think I may have already installed this one on this machine. Say OpenStack hyphen status. Hyphen, no space. Enter. Command note from here. So now say yum install OpenStack hyphen utils. OpenStack hyphen utils space hyphen y. Yeah, enter. See the repos here.
Naveen sir, this is an Ubuntu machine, so the yum is not working here.
Gotcha. Okay.
So actually, we have done the setup using a Cola Ansible on this machine.
Gotcha. Notice that here. Yeah, try pt install. Unable to locate the package OpenStack utils. Unable to locate. Can you just copy that error and paste it in chat window? Let me have a quick look at it. A bunch of commands which we can run on this one. Unable to locate. Okay, copy this one. Okay. Paste it here. Command line utils. Awesome. Rahul and Ganesh, just take a 5-minute break and come back, guys. Sorry about that. Do this. you back, Rahul?
Yes, sir.
Go ahead and share your screen. Okay. Login. So, what do you do? Yum install open apt. Just do an apt-get install OpenStack utils, just for sake of discipline.
Navin sir, sorry to interrupt. But can we postpone this practical session on Monday, because tomorrow we have the session with Ojo's team on OpenStack security purpose.
Oh, okay.
So if anything goes wrong, no, that we will in trouble tomorrow.
Okay.
That's why I will tell.
Oh, sounds good. Okay, sounds good.
Actually, we got the basic concept, and I think all others also got the basics clear.
Okay.
So can we continue with the GCPs, and from Monday we can start with the OpenStack practical.
Okay, sounds good, Ganesh.
Okay. Thank you, sir.
Thank you, buddy. Okay, so okay, just sign out this one or close this one. We'll revisit this. You come back.
Actually, we want to learn. We face difficulty during this installation.
Pardon me?
Most of the time, during OpenStack, we face difficulty during the installation. Like there are multiple ways to install this OpenStack. So we have tried using this triple O method and Cola Ansible method, but in triple O method we are not able to install. But during the Ansible, the Cola Ansible, we are able to. So we want to learn how to install OpenStack, which installation method used in the production environment, like triple O and
Yeah,
Cola Ansible.
I'm working on that one, Rahul. And
If possible, we can do it on like we can do it on AWS server or anywhere.
yeah, that's exactly what I'm also trying to play around and get it. So, so while I'm covering some of the theoretical aspects and things like that, it will take a little bit of time, right? So, I am trying it. I'm trying to get that triple thing working on AWS only. I'm playing around. I'm running into a few issues. So give me a little bit of time and I'll try to get something up for you. Okay.
Action.
Navin sir, Ganesh this side. We successfully done the setup of DevStack, Backstack, and Cola Ansibles. As Rahul told, we are stuck in triple O method.
Yeah, yeah.
So we will try this Monday.
True, true. I mean, just give me a little bit of time. I'm also trying to do that. In the meantime, if you're having any success, that is good. But if just give me some time.
Okay, sir. Okay.
I'm working on it now. Okay.
One second.
Okay. And the one that we have logged in right now is using the Cola Ansible, right?
Yeah, it is a Cola Ansible. We know that mostly in production environment, that two method we use, mostly the triple O method and the Cola Ansible. We have tried using that triple O and we are not able to install that. But the Cola Ansible was working, so we have deployed that.
True.
For POC purpose, we have done that Backstack and DevStack.
Yeah, that's right. That's exactly what it is used for. Okay, as I said, just give me some time, and I'm working on it with something. Hopefully, I will have it. I'll be able to help you. Okay. Okay. In the meantime, just log into your GCP also, Rahul.
Okay, sir. I share my screen now.
No, 1 minute. I'm probably going to cover a little bit of theory and then I'll ask you to share. So that's the clear elements. Yeah, so go ahead and share your screen, Rahul. Today we'll do a load balancing lab on GCP. Slightly time consuming, so I didn't take it up yesterday. Okay. On the left-hand side, you see the compute engine, right? Put your cursor there and you should see something called instance templates. Look for VM instance, or more precisely instance templates. Or you can just instance template. Compute engine, and below the VM instance, there is something called instance template. Yeah. And create a new instance template. Let's call it, just leave the default instance template one. And we can do first generation. Let's choose first generation N1. One moment. Yeah, for micro is good, and instead of the name as instance template one, we'll call that as web template. After you choose F1 micro, scroll up and change the name to web template. Name already used. Template F1, okay. And one F1 micro is good, okay. Scroll down. Leave the default, leave the default. That's also okay. Allow default access, allow HTTP traffic. And let's say startup script. Scroll down. There is startup script here. You should see it under, is there something like a scroll down, please? That's it, or you're there?
Yeah, it is.
Description automation here. Expand the management. Scroll down automation. Under the startup script, let's say, type in, I'll give you the script here. Let's see, type it in the chat window. Give me one moment. This page, click on OK. This is the chat window. Okay. Exclamation. Slash back. This is the first line. Let's say apt. I can get second line. Get installed. Let's say apt. Install. less than, look for less than, greater than, /var /www dot ht. Next line. Let's say less than html body h1. Say less than body less than h1. Oops. H1. Say hello. /h1. Slash. This next line. And end of file is the next one. Last line. So that will be the startup script that we want to run. One more line is sent, EOF. EOF at then, yeah. Okay. Let's see. I think we can go ahead and create it. Okay. So web template is done. Next, go to the compute engine on the left-hand side and look for instance group. Instance, yeah. Click on instance group, create a new instance group. And call it as web server. Instead of instance group, we'll call it as web server. You have single zone or multiple zone. It's already asking for instance template, right? So in instance template, choose the one we have given, web template, yeah. Choose that. And choose multiple zones. You can choose a, what is that, South one or something like that, Asia, South. That will be the closest one. South one, Mumbai. Okay. Number of instances, choose 2. Scroll down. Auto scaling. Choose the drop down for auto scaling. Off, let's say off. And scroll down. 1 minute. Cooldown period, scaling. I don't think we need to do that.
What is this instance group? Is this a load balancer?
Pardon me?
What is this instance group?
Instance group is really a group of instances, how many you want to create and things like that. So in other words, when we are doing load balancing, right, what we would like to bring up a group of instances at one time. And when we are bringing up a group, new instance, which is similar to another instance, that's where the web template is getting used. So let's say there are too many requests.
Here we need to select, right?
Yeah. Instance template also you choose as web server. Yeah, number of instances is 2. Okay, that's what I was looking for. and do not, okay, auto scaling.
These are all things for the office. Hold on period.
Utilization, okay. These, I think you can leave them the defaults. No health check should be good. Will not right now do a health check. Have you chosen the health check? Click on health check. Create a health check. Just give it a name, HC for health check. And protocol HTTP port. Leave it as 80. I think the rest of them, let's see. Health criteria, check interval is okay. Check interval 5 is okay. Just change it to 10. To unhealthy threshold to 3. Healthy threshold 2 is okay. Unhealthy threshold to 3. Click on OK. Save. And let's see. Initial delay, change it to 60 seconds. And I think if you scroll down, please.
So this is that.
Somewhere you should save it. You should be able to save it, right? See where is the save. Oh, there you go. Create it. Yeah. Give it a moment. Go back to VM instances. There's a notification there. Still working. Can you do you still have the OpenStack terminal still open by any chance, buddy? Can you just open it one more time and just look at the version of it, please? OpenStack version. Sorry about that. See OpenStack version. Space. Three dot 14.2. Okay, that's okay. Data. What's that? Oh. Can you go back to the VM instance group? Don't have it, huh? Try one more. Call it as web server something, web server 2 or something like that. Two, and choose the template as web template. Okay. Single zone. Yeah. Multiple zone. Just choose single zone for, we'll keep it simple. And auto scaling is off. Auto scale.
We need 2 instances.
Instances is 2, yeah. And minimum number of instances. Maximum number is 10 now. Is that what it is containing?
This limit.
Are you saying something, Rahul?
Yeah, it is showing this exceed limit quota for HTTP.
Yeah. Quota instance and resource web server. Quota instances. You don't have anything running, do you? Any other instances, right? Rahul?
No, sir.
Okay. Quota of instances, okay. Maximum, just change that maximum number of instances to, let's say, 5. All right.
This auto scaling is off now.
Even though we're off, we're doing off just for sake of no. Keep that minimum as 1 and maximum is 5. Scroll down. Scroll down. Cooldown period is okay. That you can leave default. Whatever healing, scroll down. Health check. Create. HC1, HC2, something like that. HTTP port. And none and request path, okay. Health criteria, check interval. Just change check interval to 10. Healthy threshold, unhealthy, you can leave the default, click on save. Oh, yeah, we also need to paste that startup script also.
That startup script we have pasted in that time.
We don't need to do that. Scroll down. Port mapping, I don't think. Okay, click on create. And just click on, while you're at it, it's an equivalent command line. Hasn't turned red or orange yet, so which is a good sign. Click on, see if you're able to click on the web server too. Yeah. So let's see what is happening. Creating instance group status. What is the template one? Timeout. Timeout.
This is health check status.
Pardon me?
This is the health check status. Maybe this is not an issue.
Yeah. Sorry, my bad. We need to give it a little bit time. Instance is being verified. Okay. Try to refresh it. But instance is stopped. Auto scaling is on number of instances true, won't change automatically. Auto scaling configurations reserved. Okay. Check. Click on one of the instances. And click on cloud login below. Oh, it says status is running, right? Scroll down. Scroll down. Machine configuration. It's okay. Keep going down. Just go back and see. Maybe it came up. Maybe we were looking at it a little too early. That is strange. Status is still not coming up. Go back into, click on the web server 2 and click on the cloud logs. Cloud login. Startup script. Expand the first one where it says web server 2. Expand. Yeah, you can click on the error also. So now expand that one. Oops. Restarting service failed to try. Unit CST service not found. What are we doing wrong? We're just creating an instance, aren't we? Can you close this right-hand side, this thing, so that we have a little real estate? Right-hand side, this recommended for use there on the right-hand side. Yeah, closer. And are you able to bring this up a little bit or scroll down? Look at the other errors. Unit UNSCD service not found. Can you just copy that and paste it in the chat window, please? Sorry about that. I did not face this issue. Copy this one. Sorry. Oops. Exclamation use, it looks good. /bin bash. Okay, so I'm thinking. We'll give one last try, like here. Open in another window the VM instance group. Keep this as it is in another window. Instance group. Type in instance group. We can remove VM and just type in instance group, or just type in group. There. Okay. So how many do you have? You have only one, right? Let's see, auto scaling is turned off. And the number of instances in group one chain or auto scaling configuration is reserved. So select that and delete that. Okay. After this, we'll create another one. This time we'll not put the startup script inside it.
So do we need to create that template also first?
Pardon me?
Do we need to require to create this template also?
No. Template is okay. I'm thinking something else.
Because in template we have pasted that code.
Oh, acha. We pasted that in the template, right? Yeah, my bad. You're right. You're right. Go back to the instance template. Click on that. See if you're able to edit it. And web server 2, scroll up. See if you're able to find the startup script anywhere. I think it's on the management and automation. It's a pretty straightforward one. Management. Equivalent reset custom data. There you go. Start. Does it give an option to edit this?
Yeah, there is
Just copy the script separately and paste it in a file. We'll run these things individually. We'll create a new instance template.
so should I delete this also?
Delete this.
Not first we need to delete the words.
The groups.
This maybe still deleting the right not yeah, now should I
Okay.
create new?
Yes. Call it as web template. I think we've given the first generation and one. Yeah. Yeah. Deploy container. It's okay. That's okay. That's okay. We can leave it.
Step
Yeah. Okay. For this test, Debian is okay. Cancel. Allow HTTP. Yeah, that's okay. You can leave the everything as default. You can create it. Now create an instance group based on this template. off. You're purposefully doing an off scale. Yeah, I think. Okay, let's choose multiple zones. Choose US. What is that? So Asia South. Asia South one. Enable instance redistribution. Asia South. Oh, that's okay. You can leave whatever this default is. Okay, CPU. Yeah, just change that to 5. Just keep it. Just for sake of discipline, I don't think it makes big difference, but I'm not sure. Scroll down. Health check. Create a health check.
Already there is.
Click on create a check.
Like,
You already have it. Okay, sorry about that. Yeah, that's okay. Shillelagh 300, I think, is okay. And create. Are you able to? Yeah, refresh it. Yeah. Click on the group. Health check is on. What is the status on the left-hand side say? Creating. Okay, that's better. In the meantime, just go ahead and I think once one of them comes up, we'll need to get into the console Google Cloud Shell. And then we'll run the 4 lines of things manually, install the Apache, as simple as that. Just give me 1 second, Rahul. I need to step out. Okay, I'm back, buddy. How to connect VMs using PuTTY? You're asking the Cloud Shell VMs, Aniket?
No, like currently we are using Cloud Shell only to connect the VMs, right? But
Ah.
ideally, it should be able to connect using PuTTY or Git Bash. So
Okay.
yeah, because every time we won't be coming to the console and like doing it via Cloud Shell, right? When we provide access to developers, they usually do directly SSH. They don't come to console.
Okay.
That's why.
Yeah, okay. Let me just look into it and get back to you, Aniket. Sorry about that. Can you refresh it once, Rahul? Wow, it doesn't take that much time. I don't know why it's taking that much time. It was pretty instantaneous for me. Can you put your cursor on the status? Ah, status. Okay. Okay. So what we'll do is we'll give it some time just to keep our time, save our time, keep our time productive. We'll give it some time, Rahul. What you do is, I'll try to come back to a little bit of theory and I'll cover that. At the end of our thing today, Rahul, at the end of the day, when these two things complete, go ahead and stop them. If you go into each of these individual VMs, you should be able to stop them. When you click on instance, and we'll restart them when we come tomorrow morning so that it doesn't take up our credit hours unnecessarily.
Okay.
You understand that, right?
Yes.
If you just click on VM instances and select any one of the instance, then after it comes up, it will give you, there you go. After it comes up, just you should find a, I think you're in the group, right? I think you need to go into VM instances, I think, to find the stop. Because, okay, so if you notice, there you go. Once they complete, they will give you an option to stop it. So you do that by the end of the day or something like that, if you can.
Okay.
Thank you, buddy. Give me one moment. Let me come back here. Network services. I think we briefly discussed about IAM yesterday. Come back. So there is IAM first project. Oops. Okay. Okay, I think this one, and also I'll ask you to share the screen, Rahul.
Should I share again?
Please share your screen. Okay, in the search, just type in IAM. The second one. And principles, click on roles. Yeah. Expand editor and expand owner. So we have compute engine default service, and Rahul Gupta is your own thing. And let's say, if you scroll down on the left-hand side, below identity aware proxy, just click on the roles there. Okay, click on AAM admin. So 60 assigned permissions, a lot of permissions here for you to search, for you to get and list and things like that. So bunch of permissions have been given under this role AM admin, whatever that is used for and things like that. But ideally, we should be able to create the roles from here. And let's see. Can you scroll, please? Scroll, please. I'm looking for members here. Just want to add a member, or on the top where you have AM admin, click on the back. There's a left hand, click on back, and you have a role. Back to roles. Click on roles. Now that's a role. Back to search IAM and go back to in the search. Yeah, click on that IAM and just one more time. Second option. Add. Click on add is the one on the top. Yeah, and you can give any email, just if you have any additional Gmail or something like that, or you can give my email also, saigraph@gmail.com. Yeah. And let's say, filter type, we have not created a role earlier. So let's say create a, scroll down please. Notebooks, platforms, analytics up. Just give a basic role. Scroll up and just give a basic role. Let's say editor. And save. Okay. So now go to the roles and search for create a new role, please. Let's create a new role. Custom role, we'll call this as, let's say, admin_finance, admin_fin. And you can leave the others default. Click on add permissions. Access, let's manage access approval. Just type in admin. Actions admin. Select actions admin. Click on OK. And these are the get update and things like that. Just select all the permissions. And just click on next, the right hand side arrow. Make sure they're also checked. Check them. Check all of them. Okay, not applicable. Click on add. Scroll down. Edit permission, scroll down. Click on create. Okay, so there is admin_fin. Now we need to go back to the members or the users we have just now created one. So yeah, go back from I am. Principals, and you can select Rahul Gupta instead of me. Now select going to that one. Okay, edit principal. Add row, owner condition, and see if you're able to. What was that admin action? I think. What was role? No, we created admin_fin or something like that, right?
Yes.
You can admin. There you go. Click on that. Save it. It can be shut down on the project. Oops. Cannot remove all of this. The action cannot be. The project must have at least one principal. Oh, what are you doing?
Yeah, this is saying that this is my. We need at least one owner.
Oh. Okay. So it's going to remove the owner rule. I'll cancel that. Come on, cancel this one and just select my email rather than your email. I did that. Just change. Yeah, select admin_fin. Save it. Okay. And let's see. So that is a role for the at a person level for an individual user. Then we have something called service accounts. And let's say what we'll do is service account, we'll do it tomorrow. And we'll try to understand difference between this one and that one, Rahul. For today, I'll stop it here. I need to get in also. And I need to get out from here into another call. Okay, Rahul. Signing off for today, guys. You guys take care and keep learning.
Thank you.
Thank you and bye for now.
Thank you, sir.